Hello, here we're going to look at 4.3, dividing polynomials. Why? Factoring quadratics can help us break down the polynomial into two pieces. In this chapter, we're going to explore polynomials that are higher in degree, and polynomial division is what will allow us to break larger equations into pieces. So this begins the really difficult Algebra 2 material. Come in for extra help if you need it. This page has long division on it. And it's actually a pre-calculus skill. It's been requested that we see it in Algebra 2. But we're actually going to start here on example 1, which is essentially 4.1 with rules of exponents. All right. Now, when you see division, there's going to be multiple ways to express that. One way to tell people you want to divide is to use a giant fraction bar. Another way is to use the division sign. Another way is to list what you want to divide by to the -1 power. Because we know that the -1 power tells you to take the reciprocal, and that's how that got there. All right, 3p squared tr in the denominator. So to do problems like this, you group up the three different pieces. So I'm going to group that, that, and that. And it's very simple. And the reason we're able to do this is because what we're dividing by doesn't have any addition and subtraction in it. So we can essentially split this into three pieces. So 12p cubed t squared r over 3p squared tr minus 21p squared qtr squared over the same denominator, 3p squared tr, and then the final piece, which is 9p cubed tr divided by 3p squared tr. And then from here we apply our rules of exponents to where 12 divided by 3 is 4. If we have 3 p's in the numerator, 2 in the denominator, that gives us 1 left in the numerator, 3 minus 2. Same thing with the t squared, 2 minus 1. When we're doing division, top exponent minus bottom exponent gives us a t, and the r's cancel. Then we move on to the next piece. 21 divided by 3 is 7. P squared will just cancel out. There's a q in the numerator, but none in the denominator. The t's cancel, and then we lose 1 r on this one. We do top minus bottom. Then for the final piece, 9 divided by 3 is 3. For the p's, top exponent minus bottom exponent leaves us p to the first. The t's cancel, and the r's cancel. So that's the answer there. So all this really is 4.1 over again. It's in this section to compare and contrast how it's different for long division. Now, this problem is different right away because we're not just dividing by one term. I'm dividing by x minus 4. All right? And so this process is pretty long. It's what I call long division. It's similar to how you used to do long division, right, back in middle school. And in the grand scheme of things, when we're doing long division, we're hoping for a remainder of 0. We're trying to divide polynomials by different factors. All right? And the reason we need this is because I can't factor this from a traditional standpoint because it's x cubed, and there's no greatest common factor to fix that. So polynomial division is the only way to address it. If we get a remainder of 0, we know the binomial is a factor of the polynomial. In other words, dividing can help us factor, and factor more complicated things than we saw in last chapter, even though you're not going to like that because some people already don't like regular factoring. All right. For the long division example, we're actually not going to look at it in this video. It's a pre-calculus skill that we're supposed to get exposure to, so at some point we'll go back and get exposure. It is useful in pre-calculus, there are situations where you have to use where you have to use long division. All right. We're going to look at, on this note, the shorter version of doing polynomial division. It's called synthetic division. It only works when we're dividing by x to the first power and then, plus or minus some number. If we were in pre-calculus and we had a scenario like x squared minus 1, we'd have to do long division, which we didn't see on these notes. Synthetic division is a process to see if this polynomial has a factor of x minus 1. All right, and I've got a chart here so that you can kind of follow along. And you may find that although this seems strange and the purpose of it hasn't really been revealed to us yet, that happens actually in the second half of the chapter, it's really not that bad. The only skills you need are addition and multiplication. All right. So one thing that's nice about synthetic division is that it only uses the coefficients. So there's those coefficients. And you might notice right away, hey, I was dividing by x minus 1. Why is the answer a positive 1? Well, synthetic division works by dividing by the potential solution to that root. And we know back from last chapter, to find a solution, you take a piece, you set it up equal to 0, and you solve it for x. So x minus 1 would have an x-intercept of positive 1, and that's why we're using the positive 1 in our chart. All right, so the blue highlighted lines were the coefficients. The 1 is because that's the solution to the factoring piece that we're attempting. And now let's see the synthetic division. The first process is the first number drops down every time. So we have the 2 on down. To get back inside, you multiply by the number in your box. So for this one, 1 times 2 gives us a 2. Now, once the numbers are on the inside, you add them up. So we're doing -5 plus 2 to get a -3. To get back inside, we multiply it by the 1. So we have a -3. Once they're on the inside, we add them. So we'll get a +2. To get back inside that final time, you multiply by the 1 one last time, and you get a 2, leaving us with a remainder of 0. All right, so I went ahead and did the whole process there for us. You can then see it step by step below. I kind of wanted you to have both there. What this allows us to do is to state this. The original polynomial was this piece. We divided it by x minus 1, and we got this as the answer. So ultimately, what happens later on in this chapter is that we'd be able to find the x-intercepts. This one's at x is equal to 1. This one would come from, it's quadratic now. You could use the quadratic formula. So that's ultimately where we're going to be heading. All right, so I've got a couple more examples here for us to look at. We'll try these two, and then when you use the answer key that's posted, you'll find that the synthetic division process really isn't that bad. So the first step is to write out the coefficients. Remember, you take the solution to your piece. So not a -2, that's my mistake. +2. You want the solution to your piece. It's very tempting to put -2 because you stare right at it, but it's actually a +2 because that would be the x-intercept, if that was a factor. First number always drops down. To get back inside, we multiply by that 2. So that would give us 6 inside. When I add them up, we get a -1. I multiply it by the +2 to get it back inside. We get a -2. Add those up, we get a 7. And then when we multiply it by that +2 one last time, we get a 14. So once again, we get a remainder of 0, which means that answer to this statement is, and I just realized we didn't cover it from the last one, so we'll go back and do that. These numbers down here tell us what the answer is. I skipped that for right there. The numbers down here at the bottom tell you what your new coefficients are. One thing that's tricky though, is you have to look, what power did you start with? We started x cubed, we divided by x to the first, which means now our next highest power of x is x squared, and we have 2 of them. And we have -3x, we have +2, because it scales on down. All right, so let's try that again here, kind of back to back. This problem started with degree 3. We divided it by x to the first power. So this tells me that I have 3x, 3 take away the 1 is squared, minus x plus 7. It's a little different when you have a remainder. We'll see that in the next one. I made a special note on this one to look out for zeros. This one has 0 regular x's. You will need to leave a spot for it in your synthetic division. So I take the solution to my piece. Coefficients are 1x squared, 0x, -3. And we do the synthetic division process. The 1 drops down. To get back inside, it multiplies by the 1. We add them up. To get back inside, it multiplies by the 1. We add them up. And then we're out of space. And this one does not end in 0. So what that means is that x minus 1 is not a factor of x squared minus 3. Later on in the chapter, we'll learn how to pick the different values that we need to try to divide by. But as for now, we're just trying different examples of synthetic division. Okay, so this one would look like, for the answer, we start at x squared. So x squared, take away 1. We're down to the x to the first power, plus 1. Now, the remainder would be -2 over top of what we are dividing by. So this guy. Remainders are a little tricky. You just put the remainder right over top of what you were dividing by. All right. Now, in the future, we essentially ignore these answers because they doesn't help us do anything. But that would be the proper way to write that answer. X squared minus 3 divided by x minus 1 would give us x plus 1 minus 2 divided by x minus 1.